In specific problem field, if you want a concept around X, you say creatively thinking ontology is a concept. You need a lot more. Just be so majority, you saying it's good stuff, it's not perfect, there's the holes, but you want to start putting up 3 seconds.
Okay. Thank you very much for attending my presentations. I'm glad to be here. My name is Jens Doerpmund. I'm with Hitachi Vantara. You know, if you don't know Hitachi Vantara, we're focusing on data management solutions like data integration, metadata catalogs, data fabric, industrial IoT with digital twins, predictive maintenance, those kind of topics. But also, we are known for our storage systems and you know, hybrid cloud solutions as well. This talk is about actionable facet-based property graph. So the focus will be on encouraging and enabling everyone to contribute to knowledge graphs, the creation of knowledge graphs, but also utilizing knowledge graphs, interacting with knowledge graphs. And when I, you know, talk about like, or say everyone, I don't just mean human beings, but intelligent applications, agents, and of course, you know, these days, you know, large language models or foundation models or whatever you want to call those, you know, as well. The work, I just want to, you know, acknowledge some of my colleagues from the Hitachi Vantara Innovation Lab and product design team that have implemented, you know, the functionality that I'm talking about. But it will be very, you know, vendor neutral, you know, I promise. So there are a few ideas. They're not really new, but taken together, right, we can accomplish, you know, quite a bit when it comes to fully making knowledge graphs kind of ubiquitous and ingrain those or include them into all our solutions. And you know, with limited amount of time and quite a few topics, so I'm going to stay at the high level, but I kind of want to give you a very brief overview. The first one is really to democratize knowledge graphs. And again, you know, the idea is to provide, I mean, to enable everyone to really interact and contribute. That's, as I just mentioned, you know, before, you know, what are kind of the best ideas there. And then it turns out that if we had a different, very simple metadata model, a generic metadata model, that would make the usability and reusability of certain graph assets much easier. We'll talk about that model, and I promise it's really simple. And it turns out that this model is really ideal for application to integrate with as well. And finally, you know, last but one point, you know, is that we would like to support lots of different graph databases, not one, right? You have a lot of experience when it comes to modeling knowledge graphs. You have your preference, you know, your favorite graph database and so on, right? And nobody should take that, you know, away from you. What I'm focusing on, though, is, you know, contributing to a knowledge graph kind of in general in a complex environment that might include edge to core to cloud, you know, lots of, you know, like shop floor and, you know, production lines, etc. Right? And so how do we all kind of contribute and what do we need from an IT perspective there? And then, you know, finally, you know, we talked about this, or I'm going to mention this generic metadata model. And it turns out that you can do a lot of things on top of this model without changing the model. It's just really flexible. And you don't need to change any APIs, you know, either. So you can be really creative and add more and more functionality. I will provide just a few examples there. So to kick this off with a motivational example, I mentioned earlier that we do a lot with storage. You see it here kind of at the bottom, and we have capabilities to create copies of data for scalability, or move data into a different data center for disaster recovery. So lots and you can put data on high-end storage, reduce latency, lots and lots of options. The problem really is that we actually don't know what we should be doing. Why? Because it really depends on what data we are talking about. How are users or applications interacting with that data? So a good example might be if you're doing a kind of real-time analysis using a BI client, right, latency really matters. If you're processing data, once in a batch process, doesn't really, matter that much. You can use cheaper storage for that. And another example might be if you knew what's inside the data. So you might have personal identifiable information, right? You had some time, you're running a profiling job, you learn more about your data. Maybe there are certain policies in place, right, that restrict you now to store the data, let's say, in a particular availability zone in the cloud, just as an example, right? So the key point really is that no matter what capabilities we have here, right, unless we understand how data is being used and what's in the data, right, we can't really optimize anything. So how do we, so we need the big picture. How do we get the big picture, right? We need to have, everyone contributing, right, their metadata into kind of a common graph, right, into a knowledge graph. And then we can figure out what the best, action is in order to reduce cost or improve latency or whatever it might be. Now, the problem, of course, is that my colleagues on the storage side, they don't really work with knowledge graphs, right? So we need to make it very easy for them to contribute, right, and define their own entities and relationships and properties. And they are the domain experts, right? So I'm not, I know very little about the properties, right, of storage volume, for instance, right? I don't want, it doesn't make sense to have a central team that's kind of defining this, right? We need to empower the domain experts to define their own types and their own, let's call it asset types. And we need to make sure that they can, interact with the knowledge graph as well. So as I kind of just pointed out, right, having a central team, right, that's curating a knowledge graph simply doesn't scale, right? So if you're part of that team, right, I'm not saying that's, it's not a good idea to have, right, teams that are really responsible for knowledge graphs, right, but we do need to democratize, knowledge graphs, somewhat, right, make them really ubiquitous. And there's three kind of ideas or three things that really make sense. The first one is if you have a complex environment, again with on-prem, in the cloud, etc. One idea is to basically provide a connector framework or a service to everyone who works with IT systems, whatever that is. And they can then implement kind of the backend, and we make it very easy to read all the metadata and or data, right, and publish that into a central knowledge graph. But that's kind of the idea. I don't need to have much more to say on this one. There was a fantastic presentation at last year's Knowledge Graph conference by someone from UBS, and it's really worth having a look at it. It was a fantastic presentation overall. But I don't think it's enough. As I mentioned earlier, right, if you just take all the metadata that you have from a particular system, let's say it's SAP or Salesforce or whatever it is, or the storage environment, and populate into a knowledge graph, you get a lot of stuff in the knowledge graph. And of course, the advantage of a knowledge graph is because it is a graph, right? We can provide lots of relationships and annotated, etc. Right? But in the end, just dumping data in a knowledge graph, it's a little bit like what we had, right, when we talked about big data and we talked about data lakes and data swamps and those kind of things. So it's a little bit better with knowledge graphs, but it would be really ideal if the domain experts can early on define, their own entities, convert it locally, and then contribute that to a knowledge graph. They are the experts, but again, the idea is to have all of this done in a decentralized way. That's the only way to scale. And then finally, if we move data into a knowledge graph, can we reutilize certain knowledge graph assets, entities, properties, relationships, as much as possible? So here's a trade-off, and this is really important to understand. Right? We don't want to force anyone, right, to follow a certain standard. But we want to encourage people, make it very easy to discover what's already there and then reutilize that when they define their own asset types. And this is kind of where I'm going to spend a lot of time on. So in order to enable this, I'm kind of defining a canonical model or generic metadata model, whatever you want to call this. And it's really embarrassingly simple, and it's also not new, right? So you find that in various places. And the idea really is that we have, three types. We have an entity, and an entity really refers to a concrete or abstract object. And that's it. It may have a type as well. So in other words, it could be like a particular person, in this room, right? You're uniquely identified, and we know your person, I think, right? And so that is basically all we really need to know, about an entity. And typically, if you define an entity, right, you're defining lots and lots of properties. And in order to make things more reusable, right, we basically group properties and give it a name and just call it a facet. Other names, aspects, and so on. It doesn't really matter what you call those. But a facet is nothing but a group of properties. And it's a named group of properties, and we provide versioning and all those kind of things, with a facet. And now you kind of get the idea, already, right, that there's a loose coupling between entities and facets, and anyone can add basically their own facets, associate their own facets with an entity, depending on what someone's requirements are. So concrete example was earlier, right? If I talk about, again, kind of a file in a storage system, someone from the storage side, right, may have a facet, that includes properties about various storage parameters, right? Whether it's more high end or not, or what file system, what volumes, and so on, right? But someone else might be on the data management side, right, may not care about those aspects at all, and they care about like what's in the data, what is the file all about, right? Or is it structured data? Does it have a schema? What are the columns? How many records are in there? Also data distributed, right? And we're talking about the same entity, but it's a totally different facet. So two different groups have totally different ideas with respect to what properties we need to capture. Now, if we didn't have this concept of a facet, then we really have the problem that we all try to force kind of the same properties into the same entity. And that is really what we want to avoid here. Relationships are just relationships, and then the whole idea is to reuse facets. And let me give you kind of another example, what reusing facet means. So imagine you care about data lineage, right? I'm using lots of data management scenarios, but we can talk about any other domain as well. When it comes to data lineage, right, you are interested in a schema and how data is being transformed. And so we can talk about a schema, therefore, and model a schema as a facet, standardize on it. You can also version it, etc. But now we can talk about a schema for a particular data set. It could be a Parquet file, CSV file, it could be a table in a database, could be a real-time data source. Think Kafka schema registry, could be the input, right, to a machine learning model, right? You have a schema there, as well. And so if you think about the lineage, right, you don't really have to focus on the actual entities, whether it's a data set or machine learning model or whatever it is, but purely the only focus that is relevant here is on a particular facet, namely, namely the schema. And I provide already an example, right, where you're reusing, facets earlier, right? Where you're reusing entities, right? So you have different people having a totally different opinion of what properties, right, they need to capture. But we are still talking about the very same, real world object or, an abstract concept. In order to make this work, this reusability, we needed to think a lot about, the API design, user experience, UI, etc. And so I don't want to prescribe anything. This is where we are utilizing a product design team. But it's when you empower everyone to create their own entities and their own their own facets. How can we, in that particular case, right, ensure that someone is utilizing what is already available, right? At the same time, I really want to make sure that we're not forcing anyone, right? If there's something there that's usable, right, if there's a definition of a schema as a facet that works for you, fantastic, right, saving you some time. If you need something slightly different, where you can even modify it as long as everything is versioned, and we're creating a new version for that. Now, I want to talk more about actionable knowledge graphs, and I'm talking about, I'm using one example here that's from video game development, and there's a very particular pattern, that is, very dominant, when it comes to video game development, and it's called ECS, Entity Component System, and it consists of, three components really. There's an entity, which is just a unique identifier. That's it. There's nothing else. There's a component that describes, some property and a state of a particular entity. And then you have a system, and the system, in order to make things efficiently, you have lots of systems. A system is just only interacting, right, with the same type of component, right, irrespective of all the entities. So concrete example is, you have a video game, and there's an entity, whatever that is, and it's moving across the screen, right? So there's a component that has the information like x, y coordinate and kind of velocity, etc. And then you have a system whose responsibility it is just to update kind of the new position right after a certain amount of time. And you can see that this is very efficient, and obviously there's a kind of a simple mapping right between kind of the entities in an entity component system, components and the facets that I talked about earlier. And so the idea really is that you can define lots of systems, services, right, that are running all the time, that are interacting with the knowledge graph, and they are interacting with the knowledge graph in such a way that they are focused on groups of properties, i.e. facets, right? Versus it needs to interact with the knowledge graph, and it needs to look for a particular property in one particular entity, right? That would never work. So this whole idea of facets really help a lot in this particular space. So concrete example, really a trivial one from that I had earlier, right? It could be a service that's just running. It checks for two facets, usage statistics and physical properties, right? Usage statistics could just be updated on a regular basis. It's whether some data is actually being accessed and how frequently. And you could, for instance, say, well, if independent of the actual entity, right? If the statistics is such that there's no frequent access, but the physical properties is kind of high end, right? Then just relocate whatever that object is, right, to cheaper storage. Or similarly, if you run a profiling job, you identify personal identifiable information, right? Then again, are there certain policies in place that require that data to be locked down, right? To change the property, the access rights, or you kind of move it into some more protected data, or move something from the cloud to on-prem or whatever it is. It's really trivial, trivial example. Now, how can everyone contribute? I have not talked about graph databases and so on. I will get there in hopefully within the next few seconds. But the idea really is, if anyone creates a new asset, so an entity or a facet, as an example, we have to create an immutable log somewhere, right? That we persist. This is a log that we can feed into any graph database, right? And then that's the tool that you guys might be working with. So completely neutral with respect to the actual database, right? But having a log allows us to support multiple databases, at the same time. We can also always reprocess the log, or selectively choose, what data is actually loaded into a database or a graph database. And these systems that I talked about earlier, entity component systems, they can operate on that event log, in real time, right? So we have kind of the best of both worlds, right? We talked about the canonical model, right? We have this immutable log, and that's what we get then into a graph database. Now, you might be saying, well, so when you load data into a graph database, at that point in time, we may have to transform the data. So this generic model that I explained earlier is ideal for interacting with the knowledge graph and reusability. But if you use, let's say, a property graph database, just as an example, there are no facets. We just model the facets as a node in there, basically as a node, shouldn't say entity. And that perfectly works. It works with any kind of database. And so some other examples, if you, let's say, said, I don't want a graph database, I need an object store. Well, in that case, you want to denormalize the data a little bit. You have an entity, right, with the facets, i.e. properties at a point in time, right? You denormalize that, store that as a document, as part of a collection in a document database. Or an example much more important, these days, you want to use the knowledge graph, right, to provide the context for a transformer model. And so the nice thing about facets is you can now really determine, right, what data really is useful for that. And then you run it through a machine learning model, generate an embedding, right, and store that embedding in a vector database, right? And you know the drill, like how that is being utilized. I'm kind of running out of time, so I can't, go into details here, right? But we have all the flexibility, and so the idea really is, however, somehow, we are, adding, right, calling an API, storing the data, right? We can populate, lots of different databases, or kind of any service that is really monitoring, very specific facets. Just a very quick example here, why this might make sense to have more than one database. So for instance, you might be interested in time travel, how certain components have changed over time. Now, it's easy to model this, right? Every time you're updating something, you're updating kind of a valid to field, but it's really, really painful, because what that really means is, here's a kind of a sci-fi example, right? My apologies if you're focusing on semantic databases with property graphs, but something equivalent, applies in probably to you as well. But here's kind of a sci-fi, example, right, where you can do time travel. You can look at the state of the database at a certain point in time, but it's just really painful to having to specify that every single time. So why don't you just do the following, right? You have your graph database, feeding the log into the graph database, you're just overwriting, and now everything is easy to use. But once in a while, when you need to do some analysis, how things have changed over time, spin up a new graph database, reprocess, the log, but now you're kind of calculating kind of a valid to field, and now you can do time travel, right? So this whole idea of having just one graph database is really not optimal. Here you have a lot of flexibility. And so let me, I mentioned we can do a lot of additional functionality on top of this generic model. And kind of want to point out the following very briefly, a couple of ideas. One idea really is that I can, for instance, define events. If I want to monitor the graph, I can define events of like what I want to monitor. In other words, I can define a new entity of type, event or notification. And in the facet, I'm specifying what real kind of entities and or facets, right, I really want to monitor, right? And then I have a service, right, that's looking for these events and configures kind of a trigger in a database, right, or an entire event system, just as an example. And the other thing where we spend a lot of time on is kind of a classification system, grouping entities, taxonomies, which we also can define using exactly, the same model, versus just trying to do all of this via relationships. So running out of time, so it's a last slide, or last but one. And it's the same scenario that we talked about earlier. So we want to do some automated data placement. The only difference here is that we are fully utilizing kind of statistical information, right, and kind of define a reward function, right, that minimizes cost and latency. And now we are basically using reinforcement learning, right, to continuously, check certain facets and actually see, right, what data format, what location, and so on is optimal for a particular use case. So can't talk about this much more. Just want to summarize this. Right, we talked about decentralizing everything, so make it easy to contribute to a knowledge graph. Right? But we are really convinced that the combination, right, of a simple canonical model based on facets and a immutable log, provides a really good foundation, for the development of services, right, intelligent services, agents, and so on, that integrate with the knowledge graph and therefore making it more actionable. So that's it. I think we may have time for 1 or 2 questions. Is that correct?
I'm curious, do you guys version your facets?
Yes, that's very important. Facets have, we absolutely version facets, gets into the immutable log, and it's really needed later on to see, all the changes. Also needed in order to encourage reusability. So you see a facet, right, that kind of works for you, but you do want to make some changes, right? Perfectly fine, create a new version, right? That's the one that you're utilizing. So the key aspect, facets are nothing but grouped properties. They have a name and versions. And when it comes to versions, you can even have different versions for exploration, etc. So it doesn't necessarily have to be a version that's only based on time, but it could really be to experiment, right, with different kinds of facets to get kind of a demo version or whatever you want to call it as well.
Why would you have 2 classes of citizen in terms of facets for entity, but you don't have facets for relationship? So why would you say entity?
We actually do. I just isn't I didn't describe this, and these are just kind of ideas. So we experimented with that, and we do exactly the same. So I'm more comfortable with labeled property graphs. That's just my personal preference. And that means that you have, entities, right, with properties, and you have relationships with properties. And for the relationship with properties, exactly what I described, makes a lot of sense as well, because now you just have more information, right, more meaningful types of relationships that are easier to share. So thank you for your question. I didn't go into a lot of details, and these are just kind of ideas that we have prototyped with lots of different scenarios, industrial IT scenarios, in insurance scenarios. So it doesn't have to be exactly these topics, right? But you have a choice to make adjustments, of course. Thank you.
What software is used to manage the facets?
So it's really, we basically store everything in an immutable log, right? And you can, how do you do that? You can use Kafka, you can do whatever, right? And then we load the data into a database of your choice. So we are completely flexible. That's when we do conversions. So I really tried on purpose to be neutral with respect to the graph database or graph databases that we want to utilize, right? So I could give you a long list, right? But it really doesn't matter. That's yeah. Thanks for your question. Appreciate it. I'll be outside. Thank you. So if you have questions, just reach out to me. I'll be around.
Did you upload them? Or?